Hello, this is Veysel Akbaş. This is a video about explanation of neural computation and control lecture, assignment 1. First, I want to thank Ms. Selma Yıldız Kayarma about this great homework, which helped me a lot to understand the logic behind neural network as much as possible. At the right side, we can see the assignment, explanation of the dataset, MNIST dataset, that created with 70,000 images from 28 to 28 pixels. And we will use TensorFlow to image recognition with some successful occurrence ratio. Then I will explain the remaining steps. Let's start with first question. As a suggestion, I'm using the Colab from Google. The first time I'm using this, and I saw that it's a great implementation supported by Google. First question is print the properties of the data, like size, shape, and dimension. Let's start with that. First, I will import the necessary libraries, the Colab, to run the program. Currently, it's downloading the libraries and necessary data. Okay, the download is completed. What we exactly download is from Google API. We can also open this, like this file. If we check this, we will see the file size, encrypted file size is 10 megabytes. When we open it, we see that we have train data, test data, and with labels. Label means explanation of this ladder number. Let's check the details with image shape. This is a train data, train image. It consists of 60,000 component, and also image size is 42 million byte. It makes around 45 megabyte. And also we can see the shape of the test data. It consists of 10,000 pictures, and the label length is every single test data has their own labels. Like this image label is 5, this image label is 4. And I'm wondering how is the quality of the image. I wanted to solve 1,000 of them. It's taking time when I run this. Let's see together. I'm plotting the sample limits from first image to 1,000 image. What I was wondering, do we have outliers? What means nearly not possible to read even by human? I saw some potential figures, and I made some tests with that. But I can say that a big portion of the image is qualified as quite well. It means we can easily understand which ladder is that. But what I mean, like example, for example, this one. Is this 0, is this 1, is this 2, or 3, I don't know. Time to time, with low accuracy, system cannot understand which letter is that. Is that 1 or is that 7? Or is it 3 or this one? Is it 1 or 4, I don't know. Okay, but I can say that the quality is quite good with checking first 1,000 pictures. And also, I want to find the complicated one. How much complicated is that? I choose the 45th image. It makes 44 when we include 0, and the image is like that. I can say this is a 4, maybe, or 9, I don't know, maybe G, but system labeled as 9. Okay, then the second question is, implement the first version of your fully connected feed-forward neural network with only one hidden layer, and not, okay, here is the sample codes that I take from the lecture notes. Thank you very much again. This means one hidden layer. This is the output layer. And note neuron quantities, 32, it means dense. And we will make 30 epochs. Here is defined like that. And I think that's all. It will take time, but we have to make it. Also, we have 10 number class here. We have from 1 to 9 and plus 0, it makes 10 number class, and we defined it here. By a mistake, during making this homework, I defined this 256 wrongly, and the results was not good as 10, I can see. I will come to that point later. Okay, the accuracy, we can say it is quite good. First trial. That's all. Let's continue with evaluation to results with test data. Test accuracy is 93. It's quite good. And let's make a prediction. I choose 60th image. And the guess is 7. As a human, I think it's not a 7. But system knows this with a great success. I choose this with checking of the big data as here. Okay. And the third question is, please try 4 other activation functions. As a suggestion above, the activations functions was ReLU, let's say, but according to lectures, we have these alternative activation functions, and I will try 4 of them more. Let's check together. All the parameters are same, but I will try Atom activation function. Wow, there was a mistake here. Sorry, yes, it's an not activation function. ALU here. This is an optimization. We will come to that point later. Okay, the alternative one is ALU trial. It's taking time, but I want to show you the results. Okay, it's also great. It worked great. Its accuracy is 93. As an alternative 2, I choose SELU. Let's see the result. The result is 0.92, a bit lower. Not bad, but lower. And the next one is the linear, alternative 4, linear activation method. And the result is 89. I would not prefer this one. And the fourth and last one, I used TAN-H activation function. And here is the results. We can see here, it's 90. It's not good also comparing with the first SELU and ALU. And the question 4 is, please change the optimiers, this one, with 4 different optimiers. Here is the note from the lectures again, as we have SGD, we used Atom already. We have ADA delta, ADA grad, RM prop. Let's see the results. Alternative 1, SGD, here is changed with ReLU. I turned back to ReLU because it was working great. SGD result is 0.2. It's terrible, I can say. I would never, here it's clearly 5, but system guessed as 3. It's not working, we can say. The alternative optimizer trial 2 is ADA delta. I choose this as ADA delta. Let's check the results. It's also not good. Accuracy is 0.3. Estimated wrongly also with this one. And optimizer trial 3 with ADA guard. ADA guard result is 0.5. A little better, but still really terrible. It's nearly randomly 0.5. And last, optimizer trial 3 with RMS probe. We changed from here, and I used ReLU again. Here is the result. It's 0.91. I can say it's also good, but the best is the first one, and it means ReLU, clearly. Sorry, Adam. Okay, let's continue with other questions. Alternative 1, alternative 2, alternative 3, and 4. And okay, the question 5. Please change the number of nodes at minimum 4 times. Okay, we are changing the nodes 4 times here. Use different increase number of nodes and to decrease number. Okay, what I made here, first I used increase the node numbers to 128, like that. Up to now we used 32 nodes, but this time I used 128 nodes, neurons. Let's see the results. It's quite good, 0.95. And a little lower with 64 nodes, changed here. The result is 0.94. It's so close, but it's normal. It's lower, and it's normal. And I decreased to 16 nodes, as you see here, and the result is 0.89. And the 8 node, very simple node, the result is 0.78. It's as we expected. Okay, question 6. Please add additional hidden layers to your network and explain the effect of the performance. For that questions, I decided to use 8 nodes to see the effect because the result was not good. And I wanted to see if we increase the layer number, I will see the results better, and it became like that already. I tried to use 2 hidden layer for 16 and 32 hidden layer. I can say the best one is 16 or lower, I don't know. There is an instruction how to decide the optimized hidden layer with that, shared by the lesson lecture. There are some suggestions for that. Here we see 2 hidden layer results. The previous result was 78. Let's see the with 2 hidden layer. It's same, we can say. There's no effect. Let's try with 4 hidden layer. It increased, but not so much. It was 0.78, and this time it's 0.8. Yes, we see improvements, but not perfect. Let's continue with 16 hidden layer like that. I'm using the ReLU activation because it works quite good. Let's see the results. Okay, the result is 0.9. Not perfect. I know the root cause. The root cause is not number 8. Let's try with like a fantasy. It's 32 hidden layer. I'm not sure, but I think it's not normal. It's so much. Uh, Here we see the results with 32 hidden layer. The result is 0.68. It's clear that more hidden layer doesn't mean better results. As we see here the results are stacked after some epochs. Okay, question 7. Please explain what type of changes can be explored further to improve the performance of the first version of your neural network. Please list and discuss. Okay, up to now, I took some notes here. What we have done, according to previous comparison, previous trials, and previous results, ELU activation function has the best results, so I decided to continue with ELU. And also, according to optimization, Adam method is the best method for this dataset. And also, 120 node trial has the best accuracy result comparing with 64. But with the new optimized one, I decided to try 256 nodes. And also hidden layer quantity, previously simulation, I decided to make this hidden layer decision like 8 because I don't see any serious effect after 8 hidden layer, I can say. Okay, by the way, by a mistake, I wrote here 256 also. Normally it must be 10, but also it will be interesting to see the results. With the next question sample, I will change it to 10 and you can see the results. Okay, the system is started to generating neural network and we solved 99 here and with the continue, the result is 97, which is quite good. But there's an abnormality here. The class is 252, normally it must be 10. Then I changed, let's remember that value, 0.97.45. I changed this softmax quantity to 10. Here is the result. We can see, okay, this one, here is the result. It's better, clearly I can say. It's 0.97.57, nearly. This is the best result up to now with this adjustment. Okay, let's continue with question 7. As a result, we achieved 0.97.57. And let's continue with the next question. Question 8. Select best model configuration and implement further improvement strategies you have discussed before. Okay, as an A, write the previous version of the neural network, and as a B, write the final version. First version of the network, the test accuracy was 0.92, which was not bad, but we increased it to around 0.97.57. This was the earliest version. We used 32 dense, 1 hidden layer at the first version, Adam optimizer, and ReLU dense. Then that was the result. Then we changed this to 8 hidden layer and 256 nodes, and we achieved to see 0.97.57, I mean 90.757% accuracy, test accuracy. I'm not an expert, but I think this is quite good. And question 9, how do you interpret performance of the neural network? Please compare your findings. As a result, as I explained before, the best activation function is, we can say, ELU, and also best optimization is Adam for this dataset. And 128 node makes the good accuracy, but when we increase it to 256, it's also working quite good. It's not memorizing. Test performance is also is quite good. I can say that hidden layer increase is not seriously helping us, but there should be an optimum hidden layer. Then I decided to use 8 hidden layer. And also even softmax class numbers affecting the results. By a mistake, as I told you, I wrote 256, but also the result was worse. So the class number must be 10. As a prediction, I choose this one number, and the number is 63 picture at the picture set above. The guess is 9. It's a 9. It's not a perfect 9, but the system says that it's 97% 9. Also, this still was the class number 256. I changed it already. And last working neural network is, we can see here, with corrected softmax number. And the test accuracy is 97.58%. It's quite good, I think. And that's all from my side. Thank you very much for this quite good questions, which helped me a lot to understand as much as possible how neural network works with Python. And to learning the Colab was great for me. It helped me a lot. Thank you very much again. Regards.